Okay, this is question number 14 now. Figure 4 shows a sketch of part of the curve C with equation y equals x squared log x over 3 minus 2x plus 5, where x is greater than 0. The finite region S, shaded in figure 4, is bounded by the curve C, the line with equation x equals 1 and the x-axis, and the line with equation x equals 3. Okay, let's pick the highlighter out. Let's highlight x equals 1, 3, the x-axis, and the equation. Table 4, or table below, shows the corresponding values of x and y with the values of y given to 4 decimal places as appropriate. Okay, highlight that, we'll need it. Part A, use the trapezium rule with all the values of y in the table to obtain an estimate for the area of S to 3 decimal places. That's important. Okay, trapezium rule, and now the trapezium rule is in the formula booklet. Now, the easiest way to remember it, if you don't want to do that, is the area is approximately equal to 1/2 times by the height. I've got a formula book next to me, just so I don't mess it up. But the way to do it is it's the first in the list, and you add on the last term, okay, and you add on 2 lots of the rest. That's the easiest way to remember it. Now we need the height of each strip. Now that is the limits taken away from each other, which is 3 minus 1, and we divide that by the height, which was 4, because we're using 4 strips. That's what it looks like. So 3 minus 1 is 2 divided by 4. Well, that's a half, isn't it? So we've got 1/2. That's a nice easy height of a strip. It's a half times a half, right? So the area is approximately equal to 1/2 multiplied by 1/2 multiplied by, now this is 3 plus the last, which is 2.2958, okay, plus 2 lots of the rest, so 2.3041 plus 1.9242 plus 1.9089. Now, doing all that on your calculator, I've just done that myself before I film this, just to make sure the video's nice and quick, and you got 4.39255. You got to that point. And then to the required 3 decimal places, as was highlighted here in the question, that would be 4.393 to 3dp. Okay, and that is part A. Nice easy use of the trapezium rule there. Yep. Look at part B then. Explain how the trapezium rule could be used to obtain a more accurate estimate for the area of S. Okay, well, let's get something down here then. You could, for example, that's the one I think the mark scheme will allow, you could increase the number of strips. Probably a fair few, but I'm just going to go with that one for part. Okay. So that's what I've gone for. Okay, and that is my answer to part B. Let's see. Show that the exact area of S can be written in the form a over b plus log c, where a, b, and c are integers to be found. In part C, solutions based entirely on graphical or numerical methods are not acceptable. Okay, so we've got then the integral between 1 and 3, they're the limits in the question, of, we've got this horrible mess. So let's write it as a third, bring the third out of x squared log x. Let's do it that way. Then minus 2x plus 5. Let's do it like that. Now, there is a specific rule I use, because this is going to be integration by parts, for the x squared log x. We're going to make the of algebra and trig. So the way it goes is you do logs, algebra, trig, and exponentials. Well, the u then will be the log x, and that's pretty much any time, because we've got a piece of a logarithm there. So that means differentiating that, so u prime is just 1 over x. That's easy to differentiate. It's harder to integrate. Then v prime will be the x squared. That's it. So v prime back to v, we'll have to integrate that. So that will be 1/9, isn't it? Of x cubed. Yeah. So we've got the bits of our integration by parts. We just now need to sub it all in and get to our final solution. So we've got 1/9 of x cubed log x, evaluated between 1 and 3, take away the integral of 1/9 x cubed in respect to x, plus the integral between 1 and 3 of that leftover bit of the minus 2x plus 5. Okay, so we've got 1/9 x cubed log x, take away 1 over 27 x cubed, integrating that, minus x squared plus 5x, evaluated between 1 and 3. This is getting a little bit of a mess now, isn't it? Move on to the next slide. Okay. So we get, subbing in 3 log 3, substituting the 3 first, minus 1, minus 9 plus 5, I think, from memory. Okay. Minus, subbing in the 1, we get just the minus 1 of 27, wasn't it? Minus 1 plus 5. I have to tidy all that up. That's 3 log 3 plus 5, take away, blimey. Calculator time for that one. Get minus 107 over 27. My word. Got some big numbers here. Which is, 5 is, how many 27s? You should get 28 over 27 from memory. Plus, bringing the power up, using the log law, that power can come up to the top, so it'll be log of 3 cubed, which is log of 27, which is what they wanted. So A is 28, B is 27, and C will be 27. Okay. Let's look at the mark scheme then, just to make sure we've done this correctly. So question number 14 uses or implies that h is 0.5. Well, we did that bit. For correct form of the trapezium rule, get the M1 mark. The A1 mark for substituting all in and getting to 4.393, which is precisely what we got. Part B, any valid reason statements, for example, so we get the B1 mark there. Increase number of strips, decrease the width, or more trapezia, one or the other, we'll get you the mark. Part C, see where all the 6 marks are coming from. Integration by parts on the integral of x squared log x, get the M1 mark for that, and the A1 mark for evaluating that. And integrating the plus C, you don't have to add that on as it's in brackets, because it's a definite integral, yeah? All integration attempted and limits used for the M1 mark, so substituting the limits. Use correct log laws, simplifies and writes in the required form. So getting down to that last line of the 28 over 27 plus log of 27, and then stating the ways of A, B, and C would get you those final marks. Okay? And that's how we can get the full marks there for question number 14.